Suppose a plus b plus c equals to pi over 2 radians. We need to show that sine of 2a plus sine of 2b plus sine of 2c, that's equals to 4 times the product of cosine of a, cosine of b and cosine of c. Okay, let us begin. So here what we'll do, we'll start our proof from the left hand side. On the left hand side we have sine of 2a added to sine of 2b added to sine of 2c. So what we'll do, first let's try to combine the first two terms, sine of 2a plus sine of 2b. So here we have a standard formula for combining two sine functions. So let's say we want to add sine c to sine d. So we have 2 times sine of c plus d over 2 multiplied to cosine of c minus d over 2. Now in our case, c here is represented by 2a and d is 2b. So means we now have 2 times sine of 2a plus 2b divided by 2 multiplied to cosine of 2a minus 2b divided by 2 added to sine of 2c. So we simplify to get 2 times sine of the angle a plus b multiplied to cosine of a minus b added to sine of angle 2c. Now here what we'll do, we're going to change sine of a plus b. To do that, we're going to take the help of the given condition. It's given that a plus b, since a plus b plus c equals to pi over 2, we can transpose c to the right hand side to get pi over 2 minus c. Now let's take sine on both sides. We have sine of a plus b, that is going to be equals to sine of pi over 2 minus c. Now sine of pi over 2 minus c, we know that's equals to cosine of c. In other words, we can say that sine of a plus b, that's the same as cosine of angle c, provided a plus b plus c equals to pi over 2. So that is going to be equals to 2 times. So in place of sine of a plus b, we can replace it with cosine of angle c multiplied to cosine of the angle a minus b added to, now what we have here is sine 2c. This also has a standard formula. We know that sine 2 theta, this is also given by 2 times cosine of angle theta times sine of angle theta. In our case here, theta is c, so sine of 2c is going to give us 2 times sine of angle c times cosine of angle c. Now from both of the two terms, what we can do, we can take 2 times cosine of angle c as the common factor. So that means we are now left with cosine of a minus b from the first term, and in the second term we are left with sine c. Fine. The next what we'll do, we are going to combine the two trig functions within the parentheses, but there's a problem here. We can only add them if both of them are same. That means both of them must be a cosine function or both of them must be sine function. Let's do one thing. Let's convert sine c to a cosine function. Again, we're going to take help of the given condition. So since a plus b plus c, that's equals to pi over 2. So here we keep c on the left hand side and transpose a plus b to the right hand side, such that we get pi over 2 minus a plus b. Now we're going to take sine on both sides since we need sine of c. So sine of c, that's going to be equals to sine of the angle pi over 2 minus a plus b. Fine. Now we know the sine of pi over 2 minus some angle, that's going to be equals to cosine of a plus b. Meaning sine of c is going to be the same as cosine of a plus b, provided a plus b plus c equals to pi over 2 radians. Okay, so now we have 2 times cosine of angle c multiplied to cosine of the angle a minus b added to, so in place of sine c, we're replacing it with cosine of a plus b. Fine. Now we can easily combine the two trig functions because both of them are cosine. We have a standard formula for it. So we are going to use cosine of c added to cosine of d. So that's given by 2 times cosine of the angle c plus d over 2 multiplied to cosine of the angle c minus d over 2. So here, let us suppose that a plus b, that corresponds to angle C, and a minus b corresponds to D. So we now have 2 times cosine of angle C multiplied to cosine of the angle. So C plus D simply means a plus b added to a minus b. That's going to give us 2 times a. So we have 2 times a divided by 2 multiplied to cosine of, so we need C minus D. So a plus b minus of a minus b, that's going to give us 2b divided by 2. And finally, that's going to give us, so here we have a factor 2 also remaining. So 2 times 2, that's going to be 4. So we have 4 times cosine of the 2a over 2. This is simply going to be equals to cosine of a multiplied to cosine of, so 2b over 2. The 2 and 2 gets factored out, leaving us with b. So we cosine of b, and then we have cosine of c, and this is exactly the expression on the right hand side. So we can verify that. So we have 4 cosine of a cosine of b times cosine of c, hence proved.